In this video, we're going to show you how to graph exponential functions, and we're going to do 4 graphs today. But before we do that, you need to know that an exponential function is written in the form y equals a times b raised to the x. All right? In other words, we're going to have 2 numbers out here, and one of those is going to be raised to a power that has an x in it. All right? Now, before we can go ahead and graph this one, y equals 1/2 times 2 to the x, we need to know a couple things. First off, on every one of these graphs, we're going to have the point 0, a. All right, so whatever number this is. So for example, the one that I have here in red, we would say that this contains the point 0, our a, which is 1/2. So I'll say 0, 1/2 right there is going to be on our graph. All right, another point that this always has is going to be 1, and then a times b. So whatever your a times your b is will also be on your graph. So here in this one, again, 1/2 times 2, my a and my b, 1/2 times 2 is going to be a 1. And so I would say that another point that's going to be on this graph is going to be, I'll put it maybe below here, is 1, 1. So we can take those 2 points and put them onto our graph over here. Use another color here, and let's say 0, 1/2. That's going to be there. And then 1, 1, of course, 1, 1 is here. All right, and because this is an exponential growth function, all right, this is a 2 raised to the power of x, we know this is going to be going uphill as we read it from left to right. Another thing with this, though, is that these all have a horizontal asymptote of 0. Now, we're going to do some shifting later, and that might change a little bit. But for right now, we can say that this has a horizontal asymptote of the line y equals 0. Let's say that y equals 0. Meaning that the only thing this can do, this graph, is it's going to start close to that asymptote. Oops, make that a little bit better here. Start close to the asymptote, and then it's going to go up through our 2 points like this. Right now, there are some teachers out there that, maybe yours, they want you to find more than just those 2 points. Right? For my class, I call that good enough, and you can kind of see what that curve is going to do. Once it gets out here a little bit, it's going pretty much straight up, okay? Now, yes, it does go on forever to the right, and that's where we were going to say our domain is going to be from -infinity all the way to the left and then all the way to the right. However, it's going way faster uphill than it is to the right. So take that with a little bit of a grain of salt. Oops, and then not the rang, but the range. Sorry about that, is going to be our y values. And we read this from bottom to top. So my lowest y value here is 0, and then it does go up to positive infinity. So from 0 to positive infinity. Now, when we've done other things in the past with some other functions, it actually does come down and hit 0. This one does not. All right, so because of that, we are going to say that these both have parentheses and not brackets, because it never quite reaches the 0 there. All right, let's do a few more. All right, the second one is similar to the first one. It's going to be y equals 4 times 1/2 to the x. I think the other one also had a 1/2 in it. But in the other one, the 1/2 was our a term. In this one, the 1/2 is going to be the b. All right, in fact, if I were to label these, I would say that a for mine is going to be 4, and the b is going to be the 1/2. Okay, so again, that's important because always that 0a is going to be on our graph. And in this one, 0a is going to be 0, 4. All right. So I might put that out here, 0, 4. And then the other point that's going to be on there is 0, not 0, but 1, ab. All right, so 1, and then a times b for us. Well, 4 times 1/2, or half of 4, you might think, is 2. All right, so 0, 4, and then 1, 2. If I were to graph those, 0, 4 is up here, and 1, 2 is right there. All right, so this one from left to right is actually going downhill. And that's important because our horizontal asymptote is still 0, but this means that it's going to represent an exponential decay. So I don't get too caught up with my students, whether they know which one's a growth and which one's a decay. If they can graph those 2 points, the a and the b, or the parts that make those 2 points up, they should be able to see exactly what's happening, whether it's growing from left to right or if it is decaying from left to right. Again, your teacher might be a little more particular with that. So for me, my students, all they would have to do is come through these 2 points and then know that their graph is going to get closer and closer to that horizontal asymptote, again, at the line y equals 0. All right, the domain for this one, again, it's going to include all of our x's from left to right, so from -infinity to positive infinity. The range, however, this one again starts at 0, my lowest y value, but it does go up forever. So it's going to be from 0 again to positive infinity, both with parentheses. All right, and that's the graph of this one. Okay, now in the next one we're going to talk about how we shift this a little bit. All right, on this problem in the next one, what we're going to see is some shifting going on a little bit. So there's more than just our a and our b. Now what we have is something up here along with our x and the exponent, right? This is what it would normally look like. There's also something kind of after it as well. So we have this -2 and -3 going on. And what that does for us is it's going to shift it left and right a little bit, as well as maybe up or down. And so this number after our x in the exponent, that is going to be like, we're going to say the general form here is y equals a times b raised to the x minus h plus k. We've had h's and k's before with like parabolas and circles and things, right? And so this h is going to be how many units it's going to shift left or right. And so like in ours, if this is a -2, it's going to be shifted to the right 2. So it's kind of like you use the opposite sign a little bit. So I'm going to say right 2. Okay, and then the k at the end, this is going to shift it up or down k units. So for ours, this is going to shift it down 3. This one uses the same sign. All right, this is going to be down 3. Okay, and what I like to do when I graph these is take away the h and the k and graph it normally, like we did in the first two problems. Okay, so it's just like for ours, y equals 1/3 times 6 to the x. Just graph that, and then after I graph those 2 points, apply this 2 and 3 to that graph and do the shifting, and then draw my new either exponential growth or exponential decay based off of that. All right, so let's do this. Again, I'm going to come up with these points based off of this original one. So the points here, we always need 0, comma a, so 0, comma 1/3. So on our graph, 0, 1/3 would be about there. And then the other one's going to be 1, comma, and then a times b. 1, comma, a times b. Well, 1/3 of 6 is 2. So 1, 2. 1, 2 is here on our graph. All right, again, typically it would have, I'm going to do this one as kind of a dotted line. Typically it would have that asymptote, and it would look like this. This is an exponential growth because it's getting bigger from left to right. Okay, so the dotted line is not going to be our final answer here. What is going to be our final answer is what I'll do in blue. All right, I'm going to have to shift those 2 dots right 2 and down 3. All right, so if I take this one, this is currently at 0, 1/3. If I go right 2, it'd be right there, and then down 3, 1, 2, 3, it's now going to be here. All right, and if you have graph paper, of course, you can be a little bit more precise than me, but that's where I'm going to say it is. This one, same thing, go right 2, 1, 2, and down 3, 1, 2, 3. I think this would be at the point 3, -1. Okay, but those aren't the only things that shifted. So did our asymptote. Instead of this being at y equals 0, it is down 3 now. So it's actually at the line y equals -3. So it will look kind of like that, right? And then my new graph, it's going to look similar, but it's going to be over and down a little bit. So I'll do this one in a solid blue, going up through my 2 dots like this. Okay, so you're going to graph the original and then shift those points either right or left or up and down how they're supposed to be. Let's do one more. All right, this last one's going to be the hardest one that we're going to do because this one also has a -a. All right, now over here, I didn't mention it before, but it says if a is negative, this is going to flip our graph below the x-axis. All right, what I mean by that, I'll draw kind of a quick one down here, is instead of going like this for an exponential growth or coming down for an exponential decay, what it's going to do instead is it's either going to go down from left to right, or from left to right, it's going to come up and get really close to the asymptote of the line y equals 0. Okay, so ours are both going to be below the x-axis if this is negative. Now, you're going to graph it the same way. Because that negative, that's when you put in your numbers, that's automatically going to make your output negative, and so it'll be below there. In other words, what I'm trying to say is if this is kind of our original, y equals -2 times 3 raised to the x, this is still going to shift those same amounts, but we're going to do the shifting later. This is going to shift to the left 1. All right, I'm going to say left 1 and also down 1 and down 1. So that is how this one is going to shift this time. But the original, if I were to graph this one, remember we need a point 0a. So 0, comma, -2, right? So it automatically will go down below the x-axis because 0, -2 is where? Below the x-axis. 0, -2 is right here. Okay, and then the other point that we need is 1, comma, a times b, right? 1, comma, a times b. So -2 times 3 is a -6. And 1, -6 is down here. Okay, now typically, again, I'm going to do this with a dotted line to represent the original. Oh, probably should be a little more curvy than that. There we go. Something like this. Okay, that's why I use a dotted line. You kind of fudge it a little bit. Okay, however, switching colors here, the new one is going to be shifted still left and down. All right, so from my original points, this is going to be left 1 and down 1. So left 1, down 1 would be here. And same thing for this one, left 1, down 1 would be there. All right, also shifted is the asymptote. Instead of the line y equals 0, this also went down 1. So it's going to be a asymptote at the line y equals -1. And so with a solid blue line here, hopefully I can get this kind of right, it would look like this. So looks very similar, but it is shifted. And it's kind of hard to tell that, but this one had a bunch going on, right? The A was negative, so it's below the x-axis. It also has those asymptotes on there. In fact, let me write out, I forgot to do this on the last one, I think, but our horizontal asymptote here is going to be that line y equals -1. The domain for every one of these is going to be -infinity to +infinity, right? We cover all of our x's. It is a function, so it has to happen. And then the range, this one from bottom to top is going to be from -infinity, but then it stops here at our horizontal asymptote of -1. That's our last y value. However, it doesn't quite ever hit there, right? Because an asymptote you approach, but you never get there. And so it is going to get a parenthesis. All right, hopefully you liked this one. If you did, until next time, keep doing your math homework fast and accurately.